Yes, students, good morning. Welcome to our video lecture. Today, we'll continue with sum number 8 of exercise 7.11. Students, after doing sum number 8, 9 and 10, we'll do the pending properties. Okay, students, now pay attention. Exercise 7.11, question number 8. The value of integral is 0 to pi by 4 log of 1 plus 10x dx. Okay. And students, I am writing the ninth sum also. The value of integral from 0 to 2 x into square root of 2 minus x dx. Okay. Now, students, pay attention which property I am going to apply. Then the answer is according to the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. The given integral we always call as result 1. After applying the property, we get this as log of 1 plus 10 of pi by 4 minus x dx. Now students, you know the basic formula tan of x minus y, tan x minus tan y upon 1 plus 10x tan y. So if I simplify, I am going to get this as integration 0 to pi by 4 log mod 1 plus 1 minus 10x upon 1 plus 10x dx. Taking LCM, we get this as integral 0 to pi by 4 log of 1 plus 10x plus 1 minus 10x is 2 upon 1 minus 10x dx. Log a by b is log a minus log b. So this will be log 2 dx minus 0 to pi by 4 log of 1 plus 10x dx. Now, this value is nothing but I, and left hand side also we have I. So I plus I twice I is equal to log 2 integration 0 to pi by 4 1 dx, which is x. So it is pi by 4 into log 2. Now this much I can write directly. So the final answer of I is pi by 8 log 2 to the base. This is, students, the final answer. So in first 10 sums we have applied most probably this property that integral 0 to a fx dx is integral 0 to a f of a minus x dx. Now students, I am doing the ninth sum. Again applying the same property according to integral 0 to a fx dx is equal to integral 0 to a f of a minus x dx. This changes to integration 0 to 2 minus x. This will be root of 2 minus x dx. So this will be simplified as only x. So if I go for simple expansion, this square inside square would be a so this is root x. So 2 x raised to 1 by 2 minus x raised to 1 plus 1 by 2 is 3 by 2. So integrating x raised to 3 by 2 into 2 by 2, x raised to 5 by 2 into 2 by 5, and limits are from 0 to 2, so you can simplify and get the answer. That much I leave for you to complete. Now, students, we are doing sum number 10. Yes, students, our next question is sum number 10, a question which has been already asked in which cat. 10 sum, students, a question which has already been asked in which cat. The question is integral 0 to pi by 2 log sin x minus log of sin 2x. Okay, students, question 10, I is equal to integration 0 to pi by 2 log sin x minus log of sin 2x dx. Now, students, pay attention. Log of sin 2x can be rewritten as, let us apply subtraction working rule. So this becomes twice log of sin x dx minus integration of 0 to pi by 2 log of 2 sin x cos x dx. Now, log of a into b into c is log of a. So here first I am writing this as log of 2 minus integration 0 to pi by 2 log of sin x dx minus integration 0 to pi by 2 log of cos x dx. Log of a into b into c, students, is log a plus log b plus log c. Now 2 log sin x minus log sin x is log sin x. So 0 to pi by 2 log of sin x dx minus 0 to pi by 2. First I am writing log cos x dx. Here log 2 as a constant we remove outside the integral, so it is 1 dx. Now here if I am going to apply the property integration 0 to a fx dx is integration 0 to a f of a minus x dx cos pi by 2 minus x will become sin x. So this will change to log sin x dx. That step I am not writing. So definitely this 2 gets cancelled. So the value of integral is minus log 2 to the basic integration 1 dx is x, limit 0 to pi by 2. So the final answer is minus pi by 2 log 2 to the base or ln2. So students, this sum, if this doesn't strike, then students it is a problem, because if I don't apply the property, then this 2 won't get cancelled, and hence you can say the sum becomes complicated. Now, students, I think we are left with 3 more or 4 more properties to do. So let us write the basic properties further, students. All of you please pay attention. The next set of properties I am going to discuss. Now, students, the next set of properties I am going to discuss. So all of you please concentrate, students. The next set of properties I am going to write integration 0 to 2a fx dx is equal to integration 0 to a fx dx plus integration 0 to a f of 2a minus x dx. This is the property which students will be rarely using in the sum. Next property, very important, integration 0 to 2a fx dx will be twice integration 0 to a fx dx if f of 2a minus x is f of x, and this would be 0 if f of 2a minus x is minus f of x. This is a very important property. Then the next property, integration minus a to a, this is also very important for MCQ, is twice integration 0 to a fx dx provided f is even, and this is 0 provided f is odd. So even odd property is also very important, students, and that is also frequently used in the sums. Okay, now students, first of all let us go for sums of even odd properties. Sum number 11, we continue. I is equal to integration of minus pi by 2 to plus pi by 2 sine square x dx. Okay, and I am writing 13th sum also. I is equal to integration minus pi by 2 to plus pi by 2 sin x raised to 7. Even if it was 17, this property, students, will work. Don't worry, 12th sum we are going to do. Now, students, how to simplify this? Let us go for checking the function. When limits are from minus a to a, same value with the negative sign to positive sign, always think application of property of even odd function. So, when to use this property is also very important criteria, students. So, when limits are from minus a to plus a, students, we definitely go for the even odd property. So, here, first of all, our function is fx is equal to sine square x. Replacing x by minus x, this will be sine square of minus x, and that is same as sine square x. So f of minus x is equal to f of x. Therefore, f is even. So this integral, according to even odd property, changes to twice 0 to pi by 2 sine square x dx. Now replacement for sine square x is what? 1 minus cos 2x by 2. So this 2 and 2 gets cancelled, and this becomes integral 1 minus cos 2x dx. Integration is x minus sine 2x by 2. Limits from 0 to pi by 2. So for pi by 2, this becomes pi by 2 minus 0. And for 0, the entire term is 0. So the final answer is pi by 2. Now here, students, in the 13th sum, our function fx is sin x raised to 7. Replacing x by minus x to check even odd functions. So this will be minus of sin x raised to 7, and that is nothing but minus f of x. Therefore, f of minus x is equal to minus f of x. So f is odd, and for odd, directly according to even odd property, the answer of integral is 0. No need to simplify further. So this is how, students, even odd property is applied in the sum. This is how, students, we have applied the concept of even odd properties. Okay, students, now we are going for questions 12 and 14. I am keeping these properties so that students can visualize that which property we have applied. Now, students, the basic even odd property we have already understood. Question number 12. I is equal to integration 0 to pi x dx upon 1 plus sin x. Okay, and also I am writing the 14th sum. I is equal to integration 0 to pi cos of x raised to 5, means cos x to the power 5. Okay, students, let us go for simplification of this. Now, this is result 1 when 0 to a. So according to property integration 0 to a fx dx is equal to 0 to a f of a minus x dx. This will work out to 0 to pi minus x dx upon 1 plus sin pi minus x is sin x. Now, if I simplify according to subtraction working rule, this is pi dx upon 1 plus sin x minus integration 0 to pi x dx upon 1 plus sin x. This is nothing but I. If I shift it to the left, twice I is equal to pi integration 0 to pi by 2. Rationalizing by 1 minus sin x, denominator changes to cos square x. So this will be integration 0 to pi by 2 6 square x minus 10x sec x. And so this is 10x minus sec x limits from 0 to pi by 2. Sorry, 0 to pi. Sorry, students, the limits are pi. To pi. Okay, so if we simplify, 10 pi is definitely 0. Sec pi is minus 1, so minus minus becomes plus. Minus 10 0 is 0 and sec 0 is 1, so 1 plus 1 2. Twice I is equal to sorry, this is also pi into forward to multiply the value of pi. So this will be twice pi. So the answer of I is equal to pi. So students, pay attention. Here, first of all, we have applied the property integration 0 to a fx dx is integration 0 to a f of a minus x dx, and then finally students, we have integrated to integrate dx upon 1 plus sin x. I have rationalized by 1 minus sin x. So students, our next sum is sum number 14. Now all of you pay attention. Here what I am doing, I am going to apply this property. Check integration 0 to 2a fx dx is twice integration 0 to a fx dx provided f of 2a minus x is equal to f of x over 2a is 2 pi. So f of 2 pi minus x will be equal to cos of 2 pi minus x, and that is equal to cos cos x, and that is f of x. So according to that property I am not writing, so this will change to twice integration 0 to pi cos x raised to 5. Now students, pay attention. What I am doing now, if I apply the property integration 0 to a integration 0 to a fx dx is integration 0 to a minus x. Cos pi minus x will be minus cos x, and so this is minus 0 to pi cos x raised to pi dx. So this becomes actually I. So I is equal to minus I. Don't cancel I and I. Or twice I is equal to 0. So answer of I is 0. So this is also, you can say, a very important concept. Otherwise, simplifying cos x raised to 5 will be a very lengthy process. So first we apply this property, integration 0 to a fx dx is twice integration 0 to a fx dx, provided f of 2a minus x is same as fx. And then I apply the property integration 0 to a fx dx is integration 0 to a f of a minus x dx. Cos pi minus x is minus cos x raised to 5, taking a negative sign outside. So I is equal to minus I, or twice I is equal to 0, or I is equal to 0 by 2, which will give us the answer 0. Here don't cancel I and I, otherwise it will be a mathematical ambiguity. So this is how, students, these properties are applied. Okay, now students, I write question number 15 and 16. Question number 15. The value of integral is from 0 to pi by 2 sin x minus cos x upon 1 plus sin x cos x dx. Okay, students. And then I am writing the 17th sum. 16th sum we will do next time. Integration 0 to a root x upon root x plus root of a minus x dx. Okay, students, now pay attention. Same property. According to property integration 0 to a fx dx is integration 0 to a f of a minus x dx. Let us call this as result 1. After applying the property, sin x will change to cos x will change to sin x will change to cos x will change to sin x. So this is the result 2. After applying the property, students, 0 to a fx dx is equal to integration 0 to a f of a minus x dx. Our traditional concept is to add result 1 and 2. So if I operate, or even if I take minus sign common, then also I will get the same thing. Okay, let us do like that. So this is minus integration 0 to pi by 2 sin x minus cos x upon 1 plus sin x cos x dx. So again we got I is equal to minus I, or twice I is equal to 0. So the answer of I is 0. Again I am telling, do not figure out and cancel I and I. This is a wrong concept. I is not an, you can say, a term. I is the value of integral. We cannot cancel it. Okay, students. Now same property. According to the same property, so this is result 1. Now after applying the property, I am not writing the property, we get integration 0 to a root of a minus x will change to root of a minus x. This is a minus x, so x dx. This is result 2. Here definitely I have to add results 1 and 2. So adding results 1 and 2, I plus I is twice I, 0 to a. Denominator remains same, so let us add the numerators, root x plus root a minus x dx. So this gets cancelled. Integration 0 to a 1 dx is x. Limits from 0 to a, so this is a. Twice I is equal to a. So the answer is a by 2. This is students our final answer. So this three properties, especially even order properties and this properties, even odd and this property, 0 to 2a, fx dx is twice integral 0 to a, fx dx, provided f of 2a minus x is equal to f of x. And it is 0 provided f of 2a minus x is minus f of x. So students, pay attention. So directly students, application of this properties are very important for which get. Write this property students, memorize these properties, and still we are left with 3 sums and 2 MCQ students. Those 5 questions we will complete in the next lecture. Those 5 sum students will complete in the next lecture. So here students will conclude the lecture. The remaining we will do in the next lecture. We are almost done with the chapter. Now only miscellaneous exercise is pending, and you have to students have exhaustive practice of integration. Check after a very long time we are concluding the chapter. This was the longest chapter of part 2, and in fact your entire syllabus. Thank you students.